Start recording. All right, so this is for the our arcade shooter game where we created under content. We created two folders. We created a maps folder that we put our level _0. That was a blank level that we created in there, and then we just created a blueprints folder. And now we're going to create our first blueprint. So if, we're going to create a game mode blueprint class. So if you right click and choose blueprint class, and then in the pick parent, see where it says pick parent class up here, then we're going to game mode base, and then we're going to name it arcade shooter underscore game mode. So arcade shooter underscore game mode. So, and I capitalized each word, arcade shooter underscore game mode. So, all right, very good. And then I'm just going to go File, Save All, or down here you can click the Save All button, which is by the content browser, and then just save selected. So, all right, so let's set the new game the default game mode. So we're going to go back into project settings. Told you we'd be going in and out of there. And you can see the default above the ones we just did, the game mode base right there, that's default game mode. If we click on that and roll it out, you should see your arcade shooter game mode right there, arcade shooter game mode. So we're setting up our default game mode, arcade shooter game mode. And then you never have to save project settings, they always save automatically, so at that point you can just go back into your level. So.
What was it default?
Arcade shooter, it was the game mode, default game mode,
Okay.
up there, and it's arcade shooter. So, all right, the next one, we're going to create a custom pawn and a player controller class for the next things. So in our content browser, go into the blueprints folder again, and then let's create another blueprint class. So right click, blueprint class. And then this time we're going to check default pawn, and all I see is pawn. I don't see default pawn, so we'll go down into all classes if you click there, and there's a search bar, and I'm going to type in default pawn. And then you'll see default pawn comes up, and you can just click on that, and then say select, or I guess you can double click it. And we'll use that. In the default pawn, we're going to rename that hero underscore spaceship. Hero underscore spaceship. All right, and then we're going to create another blueprint. So let's right click again, go into blueprint class. And this time in our pick parent class, we're going to choose a player controller. That's the fourth one down there. Player controller, select that. And this one we'll call hero underscore PC for player controller. Hero underscore capital P, capital C, and that PC stands for player controller. So now we have a new pawn class. And we also have a player controller. So, all right. So now we need to create our spaceship that we're going to have. So let's see. Let's create a new folder. So go up to click on Content folder or Content, and then right click in there, New folder, and name this Vehicles. And open up that Vehicles folder. Oh, I didn't give you the file. Let me throw the file up that we're going to use up here in Teams. One second. Totally forgot to give you guys the hours. Hour 20, raw assets, models, UFO. All right, I'm going to put the UFO into our right there. So you have to go into our Teams package, go under shared, and then download that UFO.FBX. So make sure to download that. And then once you download it, you can just click and drag it right into that vehicles folder that we just created. So make sure you get that in there. And I'm going to do the same. I've got the UFO. I'm going to just click, drag, and drop it right inside. And then when your import content comes up, you can just say import. You don't need to make any changes here. So it comes with the spaceship, and it also comes with the material for it. So the spaceship and the material. So, all right, that looks good. Let's go into our, everybody there? All right, let's go into our blueprints folder, and then let's double click Hero Spaceship to open that up. And we'll make some changes in here. I'm going to put that tab up top there, and let's see, the next step is, all right, so we're going to select Mesh Component over here in our components. If you select Mesh Component, over here on the right side where the details are, you see the current static mesh is a sphere. Let's go and select the spaceship. So we'll click on sphere, and then you'll see the static mesh there, just UFO, and it puts it in there. Now, as you'll see, if we zoom in just a little bit here, you'll notice the spaceship is way too small for the collision. And instead of changing the collision model, we're going to change the spaceship. So over here in the scale, it's currently on the X, Y, and Z, 0.21875. If you lock your scale so that you can change all three at once, just click on one of them and change it to 0.75, enter, and then it will scale up the static mesh here to match the collision model. So we want to do that. And one other thing, because if we don't do this, this isn't in the book, but I kind of figured this out, is that we need a light, because our level is really dark, and it won't show up because there's no lights in it unless we add a light to it. So let's go ahead and add a light component. So if you go over here on the left side, the components, click on add, and just add a point light is one of the common lights, point. And then I'm just going to drag it above right there until it looks like that. That looks good. I kind of like it. I guess I don't need it to be that large. I could crank that down a little bit if I wanted to. The attenuation radius doesn't need to be that large. Oh. But it does need to be bigger than that. So maybe I'll make mine like 200, works great for me. So then compile and save and go back into your level. Compile, save, go back into your level. All right, good. The next thing is that we want to set up controls for our pawn's movement that we have. So we're going to set the default pawn in the player controller classes. So let's go into our arcade shooter game mode. So it's in the blueprint folder, arcade game shooter game mode. Double click that. And if it doesn't come up on the tab, go ahead and put it up on the tab. And I want you to select over here in the details panel over here under the classes rollout, there is a default pawn class property. It's about, what, sixth one down, default pawn class. And if you select instead of the default pawn, we don't want that. We want the one we just created, the spaceship one. So I'm going to click there and look for Hero Spaceship. It should be alphabetical order. So there's my Hero Spaceship. Click that and put it into default pawn class. And then also in the over here in the player controller class, which is the third one down, we're going to select the Hero PC, because remember, Hero PC is our player controller, so we're going to change that. If you click there and go to Hero PC and select that one. So we made two changes here in this one. And then once again, we'll compile and save. It's a good idea to compile and save frequently. It's not difficult to save frequently, so we're just going to do that. All right, in our Hero Spaceship, go back to the Hero Spaceship tab. And zoom out. In our Hero Spaceship tab, in our components panel over here, we need to click on Hero. Oops, wait a minute. We're in there in the class defaults panel, in the pawn category, add default movement bindings. So we're going to add default movement bindings. The place where we find those is up here. If you click on Hero Spaceship at the top, and then we go into details, you'll see it says add default movement, but it's going to say bindings. If I pull it out a little bit, and we need to uncheck that because we don't want the default movement bindings. We're going to create our own movements. So that's why we're unchecking that, is we're going to be creating our own movements. We don't want it to use the default ones. All right, very good. And again, click compile and save. Compile and save. And we're good right now. Turning the page. All right, in our project settings, click on the Project Settings tab, and then on the left side, scroll down until you see the word Input over here. And the inputs are where we are going to set up our controls for our spaceship. Now, they've just come out with this in the last, at least the last version. Axis and action mappings are now deprecated. Please use enhanced input actions and input mapping context instead. And so I've not looked into how to use the enhanced input actions and input mappings. So even though they're deprecated, all that means is they're really not updating them and supporting them anymore. But I know they've been working for 10 years, and we're just still going to use them because I haven't looked into the other ones yet. So we're going to click on axis mappings. Click on the little plus sign next to axis mappings, and then click on the arrow to roll it out, the one that we opened, and roll out the next arrow as well. And let's name this one that we just created where it says new axis mapping _0. Rename that move right. No spaces, move right. And we're going to have 5 different keyboard events for doing it. So next to move right, to the right of it, you see where the plus sign is there. Click the plus sign 4 more times. 1, 2, 3, 4. There we go. Because you want 5 total mappings. Now, you could do this the hard way. If we want to use like A and D for left and right and the arrow keys for left and right, I could click here and go looking for these things and find where in the world there's keyboard and keyboard there. And I could go looking for all the letters and all of that. But thankfully, they've put an easier way in there. If you just click the actual little keyboard icon and then press the keyboard key on the keyboard. I want A, and then the next one down, press D, and then the next one down, click it, press the left arrow, the next one, press the right arrow, and then the last one, that one we are going to have to search for because there's not a key for it. If somebody wanted to use a game controller, we want to set it up so it would allow them to use a game controller. So that's going to be a joystick. So let's search for the word gamepad left. Gamepad left. And it's going to be that first one, the thumbstick x-axis. So gamepad left, thumbstick x-axis. And now, we can't leave them all at a scale of 1.0 because all of them would do the exact same thing. So the A key and the arrow to the left key go left. So we want those to be -1. So A and the left are going to be -1. So instead of setting up multiple axis mappings, we're just going to set up one, call it move right, but we're going to have the move left in there as well. So we can set it all up under just one of those axis mappings instead of having multiple ones. So it's kind of a cool, efficient way to do it. So anyway, A and left are -1, D and right are +1, and the gamepad controller is also +1. So we set those up. Now, the next thing we're going to set up is we're going to, let's get out of this and let's go into our Hero Spaceship tab. And now we're going to set up that functionality. So let's go into the event graph. If you click on the event graph, we're not going to use any of these three right now, so you can just right click and move those out of the way. And then let's go ahead and right click and enter move right. Type in move right. And do you see anything that looks familiar, like what we just did? When you type in move right? What did we just create?
The axis event.
Yeah, the axis event. There you go. The axis mapping. So I typed in move right. It's the one we created. And now I can take it, and it's the one that's underneath the axis events. Exactly. So not the one that's highlighted, but the one that's up here under axis events. So I'm going to click on move right. Input axis move right. From here, we're going to drag off of the executable, click and drag off of it, and type in add movement input. Add movement, and then it comes up when you start doing it. Add movement input. Right there, so I've got add movement input. And then the last thing we'll do here is if we drag off world direction, click and drag off world direction, and type in get actor right vector. Get actor right vector. And then it just comes up when you start typing. Alright, I lied, we're not quite done here, but we are done creating things. On our input axis move right, if you take the click and drag on that axis value output right there and connect it to the scale value right there. So where do we get these numbers from? Axis value, scale value. If we go back into our project settings and we look at it, there's the scale value that we set up right there. Here's our axis mapping called move right. Here's our scale value right here. And so we just connected that here so that the axis value comes from the scale value right there. And then this input axis move right is available to us because we created it in the project settings right here under axis mappings. So hopefully all that makes sense. And then we're get actor right vector because we use the positive one there and it's the right vector. So D goes right, right goes right, and then we can use the other ones for left. So, all right, compile and save. And let's make sure. All right, we're looking good so far. The next blueprint, let's go into our arcade shooter game mode. So your tab should still be up at the top. If you closed it accidentally, just double click it to open it again. It's not a big deal. And then let's go into, let's see, let's go into our event graph for this one here. And I'm going to move this over a little bit to the left. But I do want this event begin play. So the event begin play, I do want that. And we're going to drag off the executable right there. And we're going to type in spawn actor from class. Spawn actor, and mine just came up. Spawn actor from class. And I'll put that right there. Spawn actor from class. So let's click the down arrow here under class. And if we choose it, we're going to choose camera actor. So camera actor right there. Right there. So we're going to spawn a new camera and we're going to set it up as the player controller's class view target. So I'm going to drag these a little bit away from the other thing. I just like to keep my blueprints nice and clean. So. Alright, and from here we're going to click and drag from the spawn transform. You see the little orange one right there. Click and drag from that. And place a make transform node. Make transform. Make transform. Alright, and then let's set location to 001000. So the Z will be 1000. And make the rotation 0, -90, 0. Rotation is 0, -90, 0. And then we're going to place a get player to the right of the spawn camera actor here node. We're going to put a get player controller node. So I'm just going to right click out here, get player controller. So I'm going to right click, get player controller. It pops up. I'm going to put that kind of underneath my spawn actor camera actor. And let's pull off of the get player controller's return value. If you click and drag off of that, and type in set view target with blend. Set view target. All I typed in was set view, and the rest of it came right up. Set view target with blend. That looks good. And then let's connect the executables here from one executable to the other one. The return value of the spawn actor camera actor goes into the new view target. That looks good, and so far I'm happy with that. Any questions yet about that? All right, I think we're looking good. Make sure we got everything. That looks good. Let's compile, save, and let's go back into our level. And let's add a player start in our level. So if you go into the plus sign up here, the quick add, if you click on that and go to basic and see where it says player start, let's add that. Click, and let's hit play. Hit play, see, there it is. I see my spaceship, and if you use the A and D keys, the camera, so the spaceship's, is the spaceship moving or the camera moving? The spaceship's moving, right and left, check your arrow keys, right and left, make sure they're going the right direction. Everybody working?
Yeah.
Click inside your viewport before you try it. Click in your viewport, and then your control should work. Still not working? My OBS doesn't have a pause button. Pause. Did you put a light on your spaceship? Is everyone else's working?
Yeah, I'm good. I see mine.
Okay. Evan, what's that?
No.
You don't see yours?
Yeah.
Alright, I'm gonna take a look real quick. Alright, so go back to there, look like, let's see. Let's see. Let's see, where should player start? Click on player start, press it, come over here, press F. Or click in. Click player start, click press F. There.
My player start wasn't 0, 0, 0.
Yeah, this is a,
Oh, okay, mine.
yeah. 2 dash 0. Press F.
Might change your x-axis to like -250. That's how I got mine on the screen.
Yeah, your location should be Z if it does. Alright, compile and save. Play. That's it. There we go. Alright, click on the level, use your A and D keys, make sure they work. Good, use your right and left, yours working. Alright. Alright, let's keep moving on. very good. That was all of chapter 20. Yay, we did it in 35 minutes. All right, chapter 21. Very good. Be sure to do a save all. All right, let's, in our blueprint folders, go into your blueprint folder if you're not already there. We're gonna create another blueprint class, so right click again and click on blueprint class. What we're doing now is we're actually creating an obstacle based class because we're going to have multiple, we're going to have an obstacle, but we want to modify the obstacle so it's not always the same obstacle, so we're creating a base class for it, okay? So let's see, so we're going to select actor. So if you click on actor, and then let's name it obstacle. Obstacle. And let's see, and in the components panel, so let's double click the obstacle to open it up. Make sure it's, put it up there, tab it up top there. And in our components panel over here, let's add, click on the add button, and add a new sphere collision component. Not a new sphere, but a sphere collision. So you can either search for the word collision, or you can go looking for collisions. So there's one, I see collision. They're in alphabetical order by category. And so there's sphere collision, so I'm going to click on that, sphere collision. And we're just gonna leave it, call it sphere. But you see there's a default scene root there. If I hover over this, it says this is the default scene root component. It cannot be renamed or deleted. However, it can be replaced by drag dropping another scene component over it. Let's do that. Let's drag the sphere on top of the default scene root, click, and now the default scene root is the sphere, okay? So it replaces that. Now, with that sphere selected, we're going to, over in the details, the sphere radius, we're going to change the radius property. You see mine's under shape, the shape rollout, sphere radius. We're gonna change that to 50. And set the collision preset to overlap all dynamic. So you'll have to look for, you probably have to scroll down a little bit until you see the collision rollout right there. And then where the collision presets are there, make sure it says overlap all dynamic. Mine was already on that, so it looks like that's by default now. Overlap all dynamic. Then back on the left side in the components panel, add a new sphere static mesh component. So I'm going to add, now this time we are actually adding a sphere mesh component, so click on sphere. And let's rename it static mesh. Rename it static mesh. I think since then they've created a new static mesh component right there. So this was the hard way to do it, the long way, but that's okay. And let's make sure your static mesh component is selected. And over on the collision, instead of block all dynamic, select that to no collision. No collision. We don't need double collisions on it is the reason for that. We've already got a collision on the sphere collision. We don't need a collision on the static mesh component. You just don't need double collisions. So. All right, and then also in the components panel here, let's set up a rotating movement component. And so we will add, and if you scroll down until you see rotating movement component right there. It's under movement, but it's called rotating movement component. So it's down a little bit further. Add a rotating movement component, and we should be good. So we should be good. And I'm just gonna leave it, call it rotating movement. That's fine to just leave it at that. So, All right, let's make sure, let's go back to our, let's compile and save. Compile and save. And if you're not in your obstacle blueprint, go ahead and get into your obstacle blueprint. And let's open up our, let me see this. Open up your construction script, which is the middle tab in between viewport and event graph. There's a construction script right there, if you'll open that up. I move mine off to the left. And we're gonna drag the rotating movement component from this components panel, and we're just gonna drop it into the construction script right here. So you can see that, and I'll put it below the construction script. And then click and drag off of the blue output node there, and type in set rotation rate. Set rotation rate. All right, set rotation rate. And then you can see we're going to hook the construction scripts executable node to the executable node of the set rotation rate there. And then let's place we still need to determine the rotation rate. So let's put this here. Let's drag off of the rotation rate and type in random rotator. Random rotator. Not the one from Stream, but just random rotator. There you go. Does my Michigan accent come out when I say the word random? Random rotator. Maybe a little bit. Those of you born in the South can hear. What's that?
I'm a northerner, it sounds normal to me.
Yep. All right. The next thing in the My Blueprint panel, over here in variables, they've changed it a little bit. There it is, My Blueprint panel. So down here in variables, we're going to create a couple variables. Let's click on the plus sign next here to the right of the word variables, and we're going to create one called random scale min. Random scale min, and make that make it a float instead of a Boolean. Make it a float. A float means that it can be a number that has a decimal. And then let's create another one. What do you think the other one's going to be?
Random scale max.
Random scale max. You got it. Good job. So I've got random scale min, random scale max, and then let's click on the compile. Because right now, the reason we have to click compile is if you have random scale max or min selected, highlighted, over on the right side, under details, you'll notice at the bottom, it says please compile a blueprint. You can't put any default values in there until it's been compiled. It's just the way it works. So we've got to hit compile, might as well hit save while you're in there. And now notice over on the right hand side, it allows me to set default values for those once we compile. So select the min, and we're going to put that at 0.7. And then select the max, and we're going to set that to 1.5. All right, so our obstacle then is going to be scaled from 70% of normal size up to 150% of normal size is what we're trying to do here. So, all right, and then let's drag off of the executable here from the set executable, if you drag off of that, and type in set actor scale 3D. Set actor scale 3D. All right, and then we're going to place a random float in range node under it. So I'm just going to right click in my blank space here, random float in range. Random float in range. Random float in range. And then from the blueprint panel, you can see we've got a min and a max. Guess what we're doing with the min and max we created?
We're gonna amend it up.
random.
Yeah, and there's an easy way to do it. You just drag and drop them on those output channels or input channels there. So I'm gonna take my random scale min, click, drag, and drop it on the min, boom. And then take the max, click, drag, and drop it on the max, boom. And it just puts them right there. Pretty quick and easy. That's awesome. So we did that, now we're gonna hook the random float and ranges output pin into the set actors scale 3D, the new scale 3D. What do you notice about these two? The random float and range and the new scale 3D?
One's a vector.
You're gonna have to split the pin.
Yeah, one's a float and one's a vector, right? Greens are float, yellows are vector. So let's just see what happens if we connect it. Maybe it will do it for us. It'll put a conversion node in it. Look at that. Convert float double precision to vector. Click, drag, boom. So we didn't even have to do much there. And I'm gonna slide these under here a little bit more so I can bring that closer. It's just the way I like to do it. So anyway, the conversion node happens automatically. It just converts the float to a vector. Pretty cool. All right, now we need to make our obstacle move. So we've got it all set up there, the size and the rotation rate. And so that's pretty cool. So now let's compile and save also. Compile, save. And I don't have, we need to use, there used to be a rock when you created, back in Unreal 4, when you just created an empty level and used starter content, it came with a rock. And Unreal 5.7 doesn't do that. So we'll just make something up. And
Just find a rock on Fab.
yeah, we could just find a rock on Fab. So, but anyway, let's open up your obstacle if you don't have it open already. Obstacle, and let's go into our event graph. So get out of the construction script, go into our event graph. And in our My Blueprint panel, we're going to create some variables. So over here in the variables, click on the plus sign, and let's create a float variable named speed min. So speed min, and it just comes up, whatever your last variable type was, that's what it's going to make the new one, because it thinks you just want to keep creating those, which in this case we do. Speed min, create another one, speed max. And then let's create another one called current speed. Current speed. And then create another one more, called movement direction. And this one is not going to be a float, this one is going to be a vector, because it's a direction. Directions are usually vectors. If you're wondering, well, how do I know that? If you think about a compass having 360 degrees, usually it's like degrees 1, 2, 3, 4, 5, all the way through. It's usually more like a whole number. So, so it's a vector. I don't know if that was a good description, but anyway. All right, so we can set default values for all of these. We need to go ahead and compile. So compile, save. And then for our speed min, if you click on speed min, and then on the right hand side, our default value for that will be 200. If you click on speed max, and then on the right hand side, the default value will be 500. So 200 and 500. And then movement direction, if we click on that one, movement direction, you'll see there's 3 axes. There's X, Y, and Z. And we'll make it -1 on X, and then 0, 0 for Y and Z. So movement direction, it'll be -1 on the X-axis. Let's see. We're going to click and drag from the event tick, which is down here, so the one at the bottom down here. So that one, event tick. If you drag off the delta seconds node right there in the event tick, and place a float times float node. Now, you used to be able to type in float asterisk float, but that doesn't work anymore. And so if you just type in the asterisk, then it comes up with a multiply, and that's the one we're gonna use. The book says float times float, but that doesn't work anymore. They've just made it, I think they've simplified it to where it's just a multiply. And then this one looks like it automatically comes up with the float because they're green, but you can change it if you need to. If I wanted to right click on it, I could change it to any of these other options there, wildcard, integer, vector, whatever. So anyway, I just wanted you to be aware of that. Let's see, so the, lost my place. Float times float. We're gonna drag the current speed variable onto the second pin that's available right there. So drag current speed, click, drag, and drop onto there, onto that second pin down there. And then we're gonna drag from the output node of the multiply. Good? Oh, okay. Okay. I don't know if you had a question. Okay.
Sorry.
Click, drag, and drop and place a vector times float node. Well, again, we'll just put the asterisk there and put a multiply in there. And so I said vector times float. So we need to make one of these a vector. Well, this one's already a float, so let's make the other one a vector. So I'm going to right click on the second one and say to vector. So now it is a vector times float, and then we're gonna drag the movement direction variable that we created and drop it onto that vector that's right there. And then we're going to drag off of the event ticks executable and drag off of that and type in add actor world offset. Add actor world offset. Add actor world offset. There you go. All right, and then we're going to hook the, I'm gonna pull that out a little bit further. And we're gonna hook the vector times float output pin, which is that yellow vector output pin, and we're gonna hook that into the location pin of the node we just created, delta location. Boom. Right there, so it should look like that. And then from here, everybody got that?
Yeah.
All right, we're going over into the construction script. So if you click on the construction script, right there, we're going to click and drag off of this set actor scale 3D. Drag off of the executable and type in set current speed. Set current speed. And then underneath our set current speed, if you just right click, type in random float in range. Random float in range. Random float in range. Lost my place. There we are. Underneath it, and then drag speed min onto the min. Speed min, drag it onto the min. Drag speed max onto the max. And then drag the, hook the random float in range return value into the current speed node of the set current speed right there. All right.
Should we compile and save?
Yes, compile and save. Compile and save. All right, so now each obstacle will have a different speed, but the obstacles will move in the same direction down the x-axis. And let's go ahead and place several of our obstacles into the level and try the game. So compile, save, go into here. And let's see, the game goes which way, which direction? Alright, look at what direction your spaceship is going. Mine's going forward there. So I should put the obstacles, I'm gonna zoom out just a little bit and put the obstacles in front of it. So now we can take obstacles and just kind of drag them there, and you can hold the Alt key and kind of put them like that. And I don't know, I'm gonna test it. So
We need lights.
yeah, I think we're missing lights as well. Let's go ahead and add an overhead light. So let's add go to quick add, go to lights, and let's add I wonder if I could add a skylight. Let's just add a directional light though. Let's add a directional light. And let's see what direction it's actually pointing. Oh, there it goes. Make sure it's pointing downward. Which mine is a little bit, but I'm going to rotate it down even more. There we go. Alright, so it's pointing downward. Very good. I'm going to play. And still don't see him. So maybe I need to pull my if I don't see him, oh there.
I see him.
You see yours?
Yeah.
I don't even. Oh, mine are like way far away. Look at that. Mine aren't even. So you may have to put your obstacles. Remember our player start? Where did we put it? At location on the Z-axis. Mine's at 80. And so where did I put these? These are, wow, they're at 1410. So I'm going to put them down. I should just put them all at 0. Let's see. Z equals 0, and I'm going to put my player start at Z equals 0 as well. All right, there we go. Now when I hit play, they're there. Now I can see it. They were just way too high overhead. Now, if you'll notice, there was no collision. They passed right through, so we've got to go ahead and set that up. So make sure you save all, file, save all. All right, so let's create the asteroid child class. Let's see, you can create variations through inheritance. Follow the steps to create an asteroid version of the obstacle class and change the static mesh to match. So let's go into our, we're going to create a new blueprint. So go into your blueprints folder, right click, create a blueprint class. And in the parent class window there, all classes, expand that again if it's not expanded. And we're going to type in our obstacle. So you can scroll down or just search for it. So my obstacle, where's my obstacle? Okay, you have to type it in. I couldn't find it searching. So type it in. When you find obstacle, click it, select. And we're going to rename this asteroid. I used to pronounce it with only 2 syllables. Someone corrected me. It was my wife. She let me know I said it wrong, so I have to start saying it with 3 syllables. Asteroid. All right, let's double click it to open it up, the blueprint. In the components panel, select the static mesh component. There it is, click. And in the details panel, we're going to select the rock, which we don't have. So let's go find a rock real quick, or something. So I'm going to open up, I'm going to go into, where is it? View, no, asset, I guess I have to go, first of all, go into your level, and then go into window, and go into fab. And let's just find a quick rock or something. I want a free one though. Put my fab tab up top there.
There's lots of rocks.
Yeah, so I'm gonna type in, SM_rock and just see what shows up. And then under price, I'll click under show only free products.
What is beach rock?
And yeah, just pick something that looks like an asteroid rock. I kind of like this granite rock. Oh, that's a Quickcell Mega Scan. I don't think I want that one. I just want a regular rock. The coolest looking rocks are the Mega Scans. The ones that look like asteroids. You know what? Just pick one. Cliff Rock one. I don't know how. I don't care how big it is. It doesn't really matter. Add to project. That's what I want. Click. I have read. Agree to the fab license. Accept. Downloading. Cliff Rock 1 FBX. There it is. It added it to my fab. Static mesh. There it is. Yay! So I chose Cliff Rock 1. This is the one I chose. So it was free. It looks good. I'm gonna use it. You can pick whichever one you want. So, all right. Back to the the asteroid blueprint. And then we're going to click on in the components. Everybody got their rock? Has everyone chosen the rock? Okay. No?
It's not done.
Download.
I wonder if I can get it for you. Share. I'm going to put the link in there so you can get it. You already have it. You have the link though, it's just not working.
It won't let us download it from fab.
When I click add to project, it just doesn't do it.
Yeah.
That's weird. All right, hold on a second. Let me see if I can right click. Static mesh, asset actions, and I export it as an FBX. All right, I'm going to export it as an FBX for you guys. You can just get it from there. All right, let me put it in. I'm going to throw it back into here, and that way you guys can have it. Downloads. Thought I just put it in here. Did I put it in documents? Okay. All right, let me do it again. Oh, I gotta say, okay. Export, click. There was a window that came up on my other screen that I didn't see. So, all right, so there, Cliff Rock 1 FBX. I'm going to click, drag, and drop it into our shared file of our Teams folder. So now you can just take and click, drag, and drop it into your level. Let me know if that works or doesn't work. Is that good for everybody? Shelby, did that work?
Oh yeah, I'm just trying to get it to go in.
Okay. Asher, did that work?
I've downloaded it.
Okay. All right. Let's move on to the next thing then. So we'll use this one. So let me back up. Make sure you're in your asteroid blueprint. Click on static mesh over in the components. Then on the right-hand side, where it says static mesh, click on where there's a sphere in there currently. Let's change it from a sphere to the Cliff Rock 1 FBX or whatever rock you chose. Whoa, that rock is huge. So guess what the next step is? Scaling it down, that's right. So, because we're using a different rock than it uses in the book, I'm just gonna have to make some educated guesses here. So maybe like 0.2. Scale it down, wow, this thing is humongous. Maybe 0.05. That's better. It's still really large. Let me try like 0.02. 0.02. I kind of like that. All right. I'll have to see if I can find that SM rock that they use here. But anyway, this will be good for today. Reset the element 0 material property to the defaults assigned on the static mesh by clicking the yellow reset to base material. There is reset to base material. Basic shape. I'm just gonna, I don't know what is the base material here on this. I guess I'll just have to look for it. There it is, Lambert 2. So, there's only 2 materials in there, so Lambert 2, choose that one. And let's also set the static mesh location property to 0, 0, -30. So the location, 0, 0, -30. In the location. And again, we may have to go back and adjust the scale of this because I have no idea what it's going to do since we're doing a different one. We'll find out shortly. And let's do a save all. Compile, save, file, save all. All right, we still got 20 minutes left. We're doing good.
What was the scale that you put it at? Sorry, it wasn't.
I did 0.02 on all 3 axes. 0.02. It was a really huge rock. I kind of thought when the word is cliff rock, that to me says it's going to be huge. So I kind of figured it would be, but it's we're having to like super scale it down. So, all right, let's go into our Hero spaceship blueprint. And in the My Blueprint panel over here on the left, there it is. Create a new Boolean variable and name it is damaged. So go into the variables down there towards the bottom, click the plus sign, and type in is damaged. And make it, it's a Boolean, so just leave it Boolean. That's good. And then click compile and save. And then make sure, so with is damaged selected, over here on the right-hand side in the details, make sure that is damaged defaults to false. So what do you think? Is checked true or false?
Checked is true.
Checked is true. That's right. Blank is false. If I hover over it, actually it says false. So I wonder if I check it, if it'll say true now. It does. Cool. So, all right. So unchecked is false. Leave it there. In our components panel, add a new particle system. So back over here on the left side, click the add button, add a new particle system, and you just type in particle system. Yeah, they're using, you know what? I don't have any particles in here either. We may have to save that for later because the sample content or the stuff that used to come with it had a fire particle system in it, but we don't have that anymore. So we'll put it on there anyway. We just won't have a particle system to go with it.
Do you want Cascade or Niagara?
We'll do Niagara for now. We'll do Niagara for now. Let's see. Where am I? False. Add a new particle system, name it damage particle system. So, damage particle system. And we'll have to look for a particle system this week. That'll be part of your homework, is to find one. There's tons of free ones on Fab. I don't want to take time to go do that now. I want to see if we can get through this. Set damage particle systems template property to P_fire, which actually there is none in here. If you click on it, there's none. So we're going to skip that step. Maybe I'll make a mark there. Look. Let's see. No fire. Let's see. Damage particle system. Sorry, I lost my place. Set it to P_fire, which we can't do. Set the damage particle system's auto activate property to false. So down here where it says auto activate, uncheck that. Because we don't want the fire to just show up. We have to wait until there's a collision before the fire shows up. In the My Blueprint panel over on the left, create a new function by clicking the Add New button. So instead of a variable this time, you'll notice 2 rows up from the variable, there's a function, and we're going to create a new function. So if you click the plus sign, and this function is going to be called Take Damage. Take Damage. And double click the Take Damage function to open the function's event graph, which mine did automatically when I hit enter. So another new feature it looks like. So Take Damage should show up there. Click and drag from the Take Damage node's executable pin and place a branch node. So BRANCH, branch. And then drag the isDamaged variable onto the condition input of the branch. So your take damage, click, drag, and drop it onto the condition right there. And click, drag from the branch node's false pin and place a set isDamaged node. I'm going to drag off false. I'm going to type in set is damaged. There it is. Set is damaged. Set it to true. So is damaged, check the little checkbox there. So check that to true. Drag the damage particle system over here in our component. Drag the damage particle system. Place it to the right of the set is damaged node. So place it to the right over here. Boom. So it looks like that. And click and drag from the damage particle system reference node. Hold on. Click drag from the damage particle system. There it is. This one. Output pin and place an activate node there. So drag off of the one we just created. Type in activate. The activate function becomes available. Hook the set is damaged. Hold on. Let me rearrange. Hook the set is damaged node's executable output pin into the activate's input pin. And then on the toolbar, click, I'm still missing, where did I not hook up take damage? What is that here? Take damage, branch, oh. No, that's not right.
I think you have to take the is damaged.
Yeah, is damaged needs to go right there. Boom, thank you. Is damaged there, okay, false, is damaged, it's checked, it's true there. Activate. All right, And so we don't need this take damage apparently. There we go. All right, so let's talk through this. I'm gonna compile it, save it. All right, so this is the take damage. So it starts off taking damage. Does it start damaged or undamaged?
Is damaged.
It starts, well, how did we set the condition for it?
Undamaged.
It's false. So is damaged is false. So our rocket ship starts off undamaged, or is damaged means false. So if it's false, if it's true, we don't do anything. That's why there's nothing coming out of the true executable here. If that's true, we do nothing. But if it becomes false, if it's false, then we're going to make it true that it is damaged. If it's damaged, it's going to activate the particle system. The particle system it's going to activate is the damaged particle system. And the damaged particle system we don't have set up yet. We don't have it set up because there isn't one in here. So you can find one on Fab and do that. So everybody good with that? All right, good. You guys are smart. All right, click compile, click save, move on to the next thing. Compile, save. All right, the asteroid actors need to call the take damage function whenever they overlap with the pawn, and they also need to be able to destroy themselves. Follow the steps to prepare your event graph so it looks like the one shown in figure 21.5. All right, in our blueprints folder, open up our asteroid tab. Click the event graph in our asteroid tab. And click and drag from the event actor begin overlap node. See, we've already got some things going on here that's new. We'll just go with it. And so click and drag from this output right here and place a cast to hero spaceship node. Cast to hero space, spell right. Cast to hero spaceship. All right, cast to hero spaceship. Ensure that the event actor begin overlap nodes executable out pin is hooked into the cast hero spaceship node's executable in pin, which it is via parent actor begin overlap. Click and drag from the cast to hero spaceships node as hero spaceship, the blue node there, output pin, and place a take damage node. So type in take damage right there. Make sure that the executables are hooked up, and make sure that the as hero spaceship is hooked into the target, and click and drag from the take damage executable. Type in spawn emitter at location. Spawn emitter at location. All right, very good. What location do we want to use? The location of the object. So set the spawn emitter at locations node's emitter template input pin to P explosion, which we don't have. So we need to, I'm going to write that down too. P explosion. Page 287. No fire, page 385. All right, I'll have to send that to you. Or you can find an explosion. Place a get actor location node underneath the spawn emitter at location. So just right click, get actor location. And you can already guess where we're putting that. In the location of our spawn emitter at location. Alright, now, so once we take damage, there's an explosion. Do we want the spaceship to, wait a minute, what are we doing? We're in the asteroid. Do we want the asteroid to continue being there if there's an explosion? No, Shelby, what do we wanna do?
Delete, authenticate.
Right, we wanna destroy it, don't we? So now we're going to drag off of the executable, the spawn emitter location executable, type in destroy actor. Destroy that thing, destroy actor. Everybody got it? Looks pretty good so far. Alright, let's see. Compile and save. Compile. Oh, what did we do wrong?
It's because there's something.
Yeah, it's that parent thing there. I'm just gonna reconnect. I'm gonna disconnect. If you hold Alt and click on these things here, they will disconnect and just connect straight from there to there. I don't know how that'll.
It needs the other actor to be connected, that's what it's
Yeah.
there is about.
It does, doesn't it? Okay, there we go. So, yeah, just bypass the parent actor begin overlap and just put it directly in there, those two connected, the other actor into object. Looks good, it compiled. So, all right, place several asteroid actors. So go back and delete these things that you put in there. That was just for testing purposes. And now put several of the asteroid, go back into your blueprint folder, and to put the asteroids, drag the asteroids into there. Let's see, my asteroids, once again, are my location. So you may need to change your z-axis to 0. I had to. And then, all right, and then hit play. Nice. And I think I got them a decent size too. You can change the size according to what you want, but I think I got them a decent size. And I don't know if we're gonna get through it all. That's okay. We're trying hard. We're going to create a death state. So in the content browser, go to our blueprints folder, double click our hero, go to your, we have to save our asteroid. Didn't save that. Go to hero spaceship blueprint. And in the My Blueprint panel over here on the left, we're going to create another new function. So next to functions, click the plus sign. Name it on death. On death. On death. There we go. When it's in there, drag off the executable and type in spawn emitter at location. Spawn emitter at location. And then place, you can drag off the location node and just type in get actor location. Get actor location. And then drag off of the spawn emitter locations executable and place a set actor hidden in game. Set actor hidden in game. And set it to true, so you do want to check it this time because we do want it to be hidden. The on death animation or the on death emitter is going to be hidden until it's activated. So we set that to true, Drag off the set actor hidden in game executable, type in set actor enable collision, set actor enable collision. And from this, drag off the executable and type in set timer by function. Set timer by function name. Set timer by function name. All right, 6 more steps, then we'll call it a day. All right, place a underneath the set timer. Actually, we can hook it up to the which one? Hook it into the set timer by function name object input pin. So drag off of the object pin and type in get game mode. Get game mode. There we go. And set the timer by function name node's function name to, we're going to type it in, to restart game. Capital R, capital G, all one word, no spaces. Restart game. Capital R, capital G, no space. Restart game. And we're going to set the time input to 3 seconds. And then we're going to, our take damage function, if you click on it up here, if it's still up there, if not, you can double click it from the function over here on the left. But go into our take damage tab, and we're going to click drag from the branch's true executable pin. And if it's true, what do we want to happen? If it takes damage and it's, we want to, on death, the one we just created. On death, very good. We want on death to happen. If it takes damage twice, if it's on fire, that means it only gets one more, boom, and now we need the death scene. In the level toolbar, click play in viewport to test your work. So compile, save, file, save all, go into your level, hit play, and woohoo! Oh, I didn't click on it. All right. So we didn't get everything finished. I will either copy and send you what's left, because we didn't do the health. We did not do auto spawning the things. They should the asteroids should continue spawning, not just the ones we place in there, but they should consistently spawn. And then there should be a health pack coming through, and then because it's an arcade shooter, shouldn't we have a shooting function in there as well? We should. So I was hoping we could get through it all today. Didn't happen, so I'll scan those off. So that's part of your homework for this week. So finish the game, make your changes afterwards. But don't delete the one you have. And so you'll just make another level _0, make it level _1. So you make a second level with making it look the way you want it to look. So, but you cannot use the asteroid space stuff. Yes?
I'm having trouble with the clip rock thing, it's not saving properly.
Oh, okay. Let me stop recording.
For some reason the textures aren't saving right.